as you're the host. If you put your cursor to the top of your window there where your icon is.
Is that working now?
Wonderful.
Brilliant. And you seeing the screen okay?
Sorry, perfectly. Yep,
Brilliant.
that's good.
Okay. So good afternoon, everyone. Thank you for taking the time to listen to the presentation. I hope it's of interest. So I'll get started. My name's Graeme Ralph. As Chris mentioned, I'm the Principal Manufacturing Research and Development Engineer at Spirit AeroSystems, and I lead the advanced technology team who are looking at the wing of tomorrow. So I'll go into what I do in a little bit, but I'll give you a little idea about what Spirit does and what Spirit at Prestwick do. So who are we? We're quite a big company. There's 15,000 people all around the world that work for Spirit, and we make a range of different parts for aeroplanes. As you can see, we're in America, a couple of sites in Europe, and one in Asia. So this is a bit more detail about where we are. So you can see the American facilities in Kinston, North Carolina, in Tulsa, and Wichita, and Kansas, which is our headquarters. So there's over 10,000 people that work there. A site in Malaysia, and Saint-Nazaire in France, and where I'm based in Prestwick, where there's now over 1,000 people here, and we work on a range of airplane parts, mainly for Airbus. So these are our main programs in Prestwick, and we build 3 aircraft wings parts. The A320, which is the plane that's most common. It'll be about 150 seats or so, and it'll be the ones that if you've been on holiday with Ryanair and Jet2, these kind of size, one aisle down the middle and 3 seats either side. And we build 56 sets of leading and trailing edges. You can see there in the blue every month. We also build the leading edge and the centre section. You can see there in blue for the A350. That's a much bigger plane. It's very, very new, and it's made of new advanced materials I'll talk about later. And currently we build 9 of those every month, but that's increasing as they sell more and everyone gets faster at making the aircraft. And we also build a section, and it looks in the picture there quite a small section, but the plane itself, I don't know if you've ever have seen an A380, but it's a huge plane. There can be almost 600 people can get on that plane, and it's the one that will take you 9-10 hours, take you all around the world. But that doesn't sell as well, and we only build 1 set per month. So this is a little bit on each of those builds. So in our A320 line, it's an older design, and it's mostly aluminium, mostly metal material, but we use some technology to build it. So you can see there in the top left, we use robots to do a lot of the drilling, but there's also a lot of people involved doing different tasks such as painting and sealing and joining the parts together. As you can see that in the picture below that, that's where it gets joined onto the full wing, so you know what bit it is. So it's a relatively small bit of the whole wing, but we need to build almost 2 of them every single day. So it's a busy facility. So the next one, our A380. So as I said, it looks like a small section on the aircraft, but as you can see down the bottom left there, that's 2 of our operators inspecting it before it gets delivered. So it's just a huge aircraft, and you can see in the top right there with the 4 engines. They are massive, but unfortunately not as popular as they used to be. And the A350, which is a new aircraft, it's only recently in the last couple of years started flying, and it's in between 2 sizes. So there'll be 300 or so people could fit on this airplane, and it's made out of some metal, some aluminium, but also new materials called carbon fibre. And our engineers and designers come up with using new material to make the plane lighter so that it can fly further and use less fuel. It means that the ticket prices are cheaper and it's more friendly on the environment. At Prestwick, we also do a lot of design work. We have a huge design team who are looking at how do we improve how we build things today, not only at Prestwick, but also all the people that supply parts to us from all around the world, so that we can make the plane better or quicker and save money. So ultimately, the ticket costs go down and more people are able to fly. So we design everything from wing structures to engine components, down to how we actually build the parts. We design that on the computer first. So my department is one big research and development department. One half's materials R&D, and the other part where I work is manufacturing R&D. So the other half of the guys that I work with are looking at new materials. So I said earlier in the 350, new carbon fibres, glass fibres, and really the aim is to make things lighter, to make them easier to make, and also to make them the ability to recycle the material. Obviously, a plane's a lot of material when it comes to the end of its life, and we want to be able to reuse that material. So you can see down the bottom left, it just looks like some fabric, and that fabric with the right material added to it ends up becoming that huge wing skin that you can see in the top right there, and that goes onto the bottom of the A350. What you can see in the top left is a spoiler. So when the plane lands, you'll see these spoilers come up, and that helps the plane brake, and it also helps the plane maneuver. So we have developed a new material to build these spoilers out of, and that's a growing bit of work in Prestwick. So there'll be a new facility opening up in Prestwick this year, and it's because of our R&D guys who have come up with a new way of building something. So some clever people in that team. But also, when we come up with a clever design, we need to be able to build it. So that's when my team gets involved, and we look at how do we put this together. Now in A320, the old manufacturing line, we've put in some robots, but the lines in the future will have more robotics, more projection systems to help operators carry out tasks. Rather than reading a piece of paper, we'll look to project the instructions onto panels or onto parts to improve communication. So in about a year and a half or so, we'll be opening the centre you can see in the right there, and that'll be just a big area where we can have lots of machines and robots to test things and work out what's the best way to build the wing of tomorrow. And in the bottom, that's the area that we are currently designing that will go in there. So it'll have a few robots, maybe some cobots, which are smaller robots that people are allowed to get near, because today robots are quite powerful and can be quite dangerous, so they need to be fenced off. But we're looking in the future about friendlier robots that wouldn't do any harm and people can work together with, such as the ones you can see up the top left there with the two guys working away. We're also looking at how we can use headsets to inspect parts and a whole range of technologies. And a lot of the things that you see today from likes of the VR headsets that are out and that can be bought commercially, we're looking at, can we use these headsets to help people understand how to build things. And so there's a lot of skills that are changing from the traditional aerospace skills. It's far more advanced, and a whole range of skills will be needed in the future. So we have a big roadmap of technology. These are all things at a very high level that we'll be working on to improve, and all of these come together to help us make the parts that we make today. And these are some examples of the things that we do. So you can see, as I say, the virtual reality headsets. Instead of having to train operators using live parts that can be costly, we're looking to train operators in an environment where they can't do any harm, they can't hurt themselves, and if you make a mistake, it's okay. And that should help people get the skills that they need to put together these complex parts. The one below that, you can see the guy there with the headset, and he's looking at an engine, and he can go in and see how it works and look at it live rather than having to do it on the screen. You can walk around it and interact with it, and it's really quite useful. On the top right, you can see two robots that work together. One of them holds the panel, and the other one would drill the panel. And that's a big advantage because the robots don't need to take any breaks, they don't get tired, and they can work all the way through the night. And in the bottom right, where we can't use robots, we'll help the operator. So you can see there he is using pins to attach that panel to the structure. But instead of using a drawing, hopefully you can make out the small projected circles, and that lets the operator see what he has to do next. Rather than having to go away, read a drawing, he can have all the information there with him. So I hope that gives a good idea of what Spirit does at Prestwick and what my team looks to do now and for the future. So if there's any questions, I will try my best to answer them.
Brilliant, thanks, Graeme. I've got a question. Where'd you get the term cobot from?
Sorry, the volume's a little bit low there, Chris. I missed that.
Help if I had my microphone near my mouth, couldn't it? I just wondered where you got the word cobot from. Is it co-worker or that sort of thing?
It's a collaborative robot.
Well, that's a good word.
There's a lot of interest in it now because it's very easy looking in the future, and we'll design layouts and places to work that it's safer and they can work together. But when we try and put them into areas where there's a lot of people, it's very, very difficult because we need to make sure people are safe. So there's a lot of work going on now on cobots, and they're quite cool looking things, and it's quite an interesting thing.
Brilliant. Okay, can I ask you to come out of your share screen now, and so your full face on the thing? That's it, Brunson. And look, oh, the questions are pouring in. I am sorry.
No problem.
Okay, so I think we're starting with Holston, aren't we? Holston.
Oh, got you here. Okay, so yeah. The question here is, if there's a problem, do you think the VR headset will help to solve it? So that's a good question. So what a lot of work we do is with those guys that are designing. Some of the problems we find is the designers will go and do their own design, and then they'll pass it over to us, and then we'll have to work out how to build it. So what we've found is very beneficial is if we work together, and sometimes it might be designers in a French plant or in America. So it sometimes can be quite hard to communicate, but if we've both got a headset on and we can look around their design, we can see the problems, it helps us understand if there's going to be issues. So it definitely does help solve problems and lets people understand better what we're trying to do. I've got a question from Harley at Holmeston as well. What made you choose to be an engineer? That's a good question. I love planes. I think they're amazing. I've always wanted to know how they work, and in finding out how they work, you find out a bit more about how they're built, and then find out how they're built. I really wanted to be part of that. And I've worked in a few jobs at Spirit and looking at checking parts and making sure things are right, and then being interested in trying to make things better. And then that's where what today we get to come up with new ideas. Sometimes things don't work, but the good thing about that is you learn a lot from the things that don't work, and it lets you know the next time you want to do something, maybe a better way of doing it. I've got a question here. How did you become an engineer? So I went through an apprenticeship, and I spent years training, going to college, and then working, going to college, say, certain days, and then going into Spirit certain days and learning all about the business, going through around different areas to learn what I was good at, what I liked to do, and eventually going into a department that I was interested in and my skills suited. So that was the way I became an engineer. What skills do you need to do research and development in AeroSystems? That's a very good question, and it's yeah. There's no one answer to that. In our team, we have a range of different skills. We need people who can do the obvious things like work on robotics, understand how structures go together. But we also need people that can do project management. We need people that have got good finance skills, because we can spend a lot of money in research and development, but we've got to be careful that it's worthwhile. We need people, most of all, we need people with imagination, so that they can come up with new ideas. Sometimes the ideas seem crazy, but it's surprising how many times the crazy ideas can turn out to be very, very good. So yeah, imagination, I would say. I backed up by maths and physics and a range of other subjects that I'm sure you guys are familiar with. When did you decide to become an engineer, and what inspired you? So really it was working on watching planes. I did a work experience a long time ago at the air traffic control at Prestwick, and as much as I enjoyed their job, I'm more interested in how the things are made and how things go together. I think it's very, very interesting. So what plane do we build that goes up the highest? Well, that's a very good question. It would probably be the A380. So the general rule is, when you're wondering how high a plane flies, is that the further it goes, the higher it will get. If you're just going from, say, Glasgow to London, maybe, you don't need to get too high, because you'll take more time getting up and then you'll be ready to come back down again. But if you're going from, say, London to somewhere in Australia, like Sydney, then you'll want to get up quite high, and that means the plane can cruise at the most efficient height. So that's a good rule to apply if you're wondering how high the plane's going, if you're wondering that in your next holiday. So a question here from Holmeston. How do the engineers put the parts of the planes together? So traditionally, years and years ago, planes were held together by things called rivets. And what a rivet does is you put the two parts together and you drill a hole, and then you put this rivet in the hole, and then two people will use rivet hammers and squeeze the rivet, and it creates a kind of clamp. Nowadays, it's more like nuts and bolts that hold them on. But in the future, we're looking at all sorts of different ways. How do we put aircraft together? Because the quicker it can be and the cheaper it can be is better for the airlines. So even crazy things like gluing parts together. There is some parts on planes, especially on the A350, that are actually glued together. So again, it's one of those crazy ideas that's now flying. Asked, is my job hard? It can be hard. It's sometimes difficult to see a solution, or to work towards a solution. It can be a lot of hard work, but ultimately the hard work can be very, very rewarding when you come up with something that works, or something that goes into the production line and makes a big difference, or that makes someone's life easier, or it brings a bit of work to the site. It's generally, if it's hard and you succeed, it's even more satisfying. One here is, do you worry that the robots will end up taking all the jobs? You know, I think a lot of people think that the robot will just replace the person. But what you've got to remember is that if the robot replaces 5 people doing the actual job, you still need someone that programs the robot, someone that maintains the robot, and someone that develops the process that the robot's doing. So the challenge that we've got is that other people can do things cheaper. So we need to do things smarter. And I think in the future, there'll be jobs that we don't even know what they are yet. But I don't believe that the robots are going to take everyone's job. I think that's people just being worried, which is understandable, but I can't see that happening. So I've got, what's the most interesting part of my profession? There's a lot of satisfaction, and it's interesting when you see things working. But my favourite thing is when we test some of the more surprising and the more out there things. So one thing we're looking at right now is, instead of making parts how we make them today, which is machining or bending or the kind of old style of making things, is now we're looking at, can we print parts? Can we actually use 3D printers to print metal and materials like that? And can they be replacements for the parts that we make in a different way today? So how do we make planes fly because they're so heavy? Yeah, they are incredibly heavy. So it helps a lot these days when we put these new composite materials. Some of the parts that are metal in old planes are very difficult to even lift, but the composite parts are lighter. So that makes a big difference, but they're still very big and very heavy. So what helps that a lot is the power of the engines. These engines are, I'm sure you'll have heard them before, even in planes flying overhead, you can hear them. They're incredibly powerful. And other engineers working on companies like Rolls-Royce, they work to make the engines lighter and more powerful so that we can, so that planes can fly more efficiently. Have you designed anything else? Why aircrafts? Well, yes. For a few years, I started at Spirit. I went and joined BAE for 3 years in the middle of my career, and I worked on naval ships. So completely different. A lot of the same challenges, but a completely different product. And using big welded steel and huge, some huge ships, and that was very, very interesting. But when the job came up, I was offered the job to work on the Wing of Tomorrow. I was tempted back to Spirit, and I'm glad I was. It's a very interesting area. How many planes have you helped to make? Oh, that's a great question. So I've been involved, probably the easiest way to answer, and the one I know for sure, is I've been involved since the start of A350. One of our processes drilled the first hole in the A350, and now there's 360 of those. There'll be about 200 flying now. So yeah, so well over 300 planes. Is there a supervisor for the robots? Now, yeah, that's not a supervisor how you would think there was. So one of the things that we look at is the robot doing what you expect it to do, because some things go wrong. So we have smart pieces of equipment that we call metrology. And really all metrology means is we use cameras and lasers and equipment that can measure things that are happening. And we are basically looking over the robot's shoulder all the time, but it can very, very quickly tell it, no, you're in the wrong place or you're doing the wrong thing, and it corrects it. And a lot of the things, these metrology equipment are what we use to make the robot safer. So if you were walking near the robot and maybe you didn't notice it was operating, the metrology system would look around the area, and if you got within 10 meters, it would slow down. If you got within 5 meters, it would go even slower. And if you were close enough that the robot could potentially hit you, the robot would completely stop. So that would be the robot supervisor. So there's lots of systems in place to keep everyone safe. So what are the benefits of engineering? Well, there's not a single thing, unless it grows and is alive, there's not a single thing that you probably interact with or use on a day-to-day basis that hasn't been engineered. There's obvious things like planes and bridges and boats, but even your table and chairs that you're sitting at now, someone will have designed them, someone will have engineered the manufacturing method. So there isn't many things that aren't engineered, and really engineering's about making things better. So making them better for people, making them better for the environment, and making a difference. So it can be a very satisfying profession. How old were you when you became an engineer? Well, I started my apprenticeship when I was 18, 19. Pretty much when I left secondary school, I did my Hiles, it was back then. I don't think it's Hiles now, so longer ago than I care to think of. So do we build anything else? So not at Prestwick at the moment, but we are looking at trying to do different things. It would still be within aircraft, but it may be parts such as the fuselage, which or the front parts, or the part that you sit in. So other structural parts that are built in a similar way, but using the skills that we've got in other areas, we could potentially look at doing things like that. Oh, here's a good question from Holly at Homeston. What training did you need to become an aircraft engineer? So through the apprenticeship, I was taught the basic hand skills so that I could appreciate what the guys do. How do you put things together? How do they drill the holes? How do they put the fasteners in? And then from there, how do the designers come up with what they do? How do they use? They no longer use traditional drawings. They're doing them on computer-aided design. So, like drawing packages on computers, how to use them, how to use lots of different software packages. A lot of it is done on computers nowadays. But there's a big part of it that's learned through the experience, carrying out these jobs and projects and things like that. But as far as education goes, I've done a lot of work on it's all mathematics, physics, and the traditional engineering skills. But what's also very useful is English. A big part of being an engineer is how to communicate with people. We need to talk to people from America, which isn't too hard, but we also need to talk to people from France, from Germany, from Malaysia, and it's important that you're clear in communication. It's very, very important. I've got, how do the jets actually work? From Harry. I won't do that question justice, but basically the big fan at the front draws lots of air in and compresses it. So there's energy in the air. Then a little feed puts the fuel into the air, and there's a little ignition that burns it. And then that air whooshes through the engine, and it drives these other blades, and those are the blades that drive the original compression, and then it rushes out the back. And then when you study a little bit of physics, you realise that that air rushing out the back is enough to push the aircraft forward. So that's where all of the maths goes towards. It's a lot of maths and a lot of physics, but really that's it in a very, very simple answer. Jack from Bexley Grammar, how long on average does it take to build a wing? Oh, that depends on the program. So an A320, we need to build 2 a day because they're selling them very, very quickly. But we've been doing those a long time, and they're quite small, so we're quite good at them. On A350, it's more like 2 a week, but they're much bigger, the material's more difficult, but they're all flowing through our factory at the same different stages, so there's a lot of wings being made at the same time at once. What is the best thing about being an engineer? I think, as I was saying, just being able to do something and make a difference. It's very, very satisfying when something that you've worked on becomes real and it gets used, and that's brilliant. So, robots are dangerous. Has anyone ever been hurt by one? I'm sure in the past that people would have been. So what generally happens today with robots is they get put in fenced areas and you can't get near them. But a lot of the systems, like the metrology systems and things like the cobots that are coming in, they are aimed at working with people. So they're made very, very safe, and it won't be one thing that will stop something happening. There'll be lots and lots of things in place so that no one ever gets hurt. What is the hardest part of making planes? The biggest challenge that we find in the industry is we have lots of suppliers from all over the world, making some very small parts and big parts, and it's very difficult for the guys that work in the supply chain side of things, looking after these suppliers, to make sure they all come together at the right time so that we can put them all together and supply that to Airbus. It's a very big challenge, especially when I started at Spirit over 12 years ago now. We built 15 of those A320s a month. Now we're at 57 and we're looking to get to 75. So we need to be faster at building, but we also need everyone else to give us the parts quicker. So that's a big, big challenge, because there's lots of the suppliers as I say, from all over the world. Eva from Holmeston, are there stairs inside a plane? So yes, there is on the A380 and which is Airbus, and the Boeing 747. It has 2 floors, so you can go up the stairs, and there's even more people up there. And some of the planes now, you can go upstairs. If you've got lots and lots of money, you can go upstairs and stay in your own little room. But that's for very, very rich people. But yep, there is stairs in planes nowadays. How many robots are used to make planes? Well, in our A320 build, we have 4 of those robots. In our A350 build, we have 6 robots. There's none in A380, but on the wing of tomorrow, we're looking at anywhere between 10 robots up to 30 robots, depending on things like the cobots and how they work with people. So it's increasing. Will robots in manufacturing wings take over from people? So as I say, we'll get the robots to do the hard jobs that no one wants to do. And then we'll get to do all the cool jobs like programming them and testing them, changing them. And the things that what robots are very, very useful for is doing the same thing over and over and over again. And those are the jobs that people don't want to do. There's a lot of cooler jobs coming that people will be more interested in doing. How long does it take to train to be an engineer? So there's lots of different ways to do it, but the way that I did it with an apprenticeship, that took 4 years. But it was 4 years of learning in the job and learning at college and then eventually at university. So it was a good way to do it because you got to learn lots of things at college and university, and then but you also got to see why you're learning it when you're doing the work. Will robots make engineering jobs limited in the future? So no, they'll do the opposite for us. With the robots coming in, we're earning more work. We're having to build planes faster, and they'll help that. But we'll still need designers. We'll still need all the people that support all that work. So we're currently employing more and more people. We used to take in 5 apprentices every year on average, and this year and last year we took on 15 a year. So it's helping us do the bits of work that we don't want to do and do it more efficiently so that we can have more people doing the interesting bits of work. Why did you choose to build planes? Would you be interested in designing anything else? That from Ruby, that's yeah. I think there's other things, and we're quite lucky as we work a lot with engineers from other companies. So there's places a place down in England, which Sheffield University run, and what they do is they have a big facility with lots of different companies that make cars like Jaguar and Land Rover. Airbus are there, Boeing are there. People from lots of different industries come together, and we do a lot of development work together, because a lot of the things we're doing, trying to do, are the same. So instead of us all just doing our own thing, we come together, and the government help fund us so that we can do lots of cool stuff and lots of different stuff. So that's something that's grown, and these type of centres are now, there's one of them up next to Glasgow Airport, and that's going to grow as well. So there's lots of collaboration, as we call it, working together to try and achieve something. Have any of the aircraft designs ever been unsuccessful? From Poppy. Yeah, there's some bad designs that come through, but there's so many processes to stop them becoming part of the aircraft. So someone might think it's a good idea to design something in a certain way, but there's people that check that, and then we test, and then we feed back, and it takes a long time to change a design in a plane. But that's because the planes are very, very safe, and they need to be very safe. So just check the next one. So how powerful are plane engines? That's there's probably better information than I'd know, but knowing the weight of some of the structures, if I would hazard a guess that it would be the same power as, say, 10,000 car engines. Now that's a rough guess, but extremely powerful. Was this always your dream job? So when I was very, very young, I would have liked to have been a pilot, but that when I got more interested in planes, I was more interested about how they go together. So as much as I like flying, I prefer testing and trying different things, and I think it's more interesting because it's can be something different every day. What's my favourite type of plane? Oh, brilliant question. I like the A350 a lot because I was working on that from when it was just a drawing. But my favourite plane, and it's sad that there's not as many of them anymore, is the A380, just because it's huge. And so when you see it take off, you wonder if it's going to get off the ground. It's so big, but it's a brilliant plane. There's a brilliant question from Blake in Primary One in Holmeston. How do you make the suspension work on a plane? And that's very difficult because the weight and I'm sure if when you've come back from your holidays, if you've been flying anywhere, you'll feel the thud when you hit the runway. It's even if it's a nice landing, it's still quite powerful. So there is a huge thing built into the base between the wings called a landing gear. And this landing gear is made of very tough material. It's made out of titanium and a material called Inconel, and they're very, very tough. And there's lots of suspension, and it takes a big impact. So there's places down in England that build them, and they have big testing facilities that they have to test the impact of. So it's very big forces. So it's the materials that they use that make the suspension work and makes it very, very tough. What job would you choose if you weren't an engineer? I think I would have liked. I would be a pilot then, or working maintenance guy as engineers. But I think I would still be like to be involved in planes of some sort. How?
Right.
Oh, sorry.
I think all the schools have gone.
Oh, perfect.
Yeah. So all done. I mean, brilliant. Thank you very much. It's a Friday afternoon, I think, and I think that's the difficulty of holding one of these at Friday afternoons. That they all shoot off early.
No bother.
Otherwise, it was great. Cheers, mate.
No problem.
Would you mind doing another one in March?
If you send me a date, I'll see what I can do. It should be
all right, mate. Yeah. Excellent, brilliant. So I'll do that, and I'll tell you how many, or an approximation of how many pupils are on as well, and schools, and so I'll email you shortly with that. So brilliant. Thanks a lot, mate. It's good. Excellent. Great. And we'll get the recording up onto YouTube shortly as well. So it'll be fun.
Right, thanks very much,
right,
Chris.
Mate. Have a great weekend, and
I'll hear from you soon.
I'm just going to make myself host so I can close it off. And and we'll call it a day. Cheers, mate.
Right, have a great weekend.
And you, mate. Bye bye.
Cheers, Cheryl.